In today's walkthrough, we'll be going over question 2.1 on the week 5 worksheet. So, the problem states that Agent 0 is coordinating a highly sensitive operation with a network of 6 spies to infiltrate an enemy facility. To maintain secrecy, messages are sent in coded packets via different routes. However, due to interference and the risk of interception, some packets may be altered or lost. Agent 0 decides to use error-correcting codes to ensure the message's integrity. Part A says, Agent 0 wants to send an operational code to the spies that is split into 6 parts. To ensure the message can be reconstructed even if one part is corrupted or lost, what scheme should Agent 0 use? Okay, the idea here is we can use a polynomial of degree 5, where p of 0 is the code, and we're going to send p of 1 to p of 6 to the spies. And we know that a degree n polynomial is uniquely determined by n plus 1 points, right? So if we send p of 1 to p of 6 to the spies, they can reconstruct this polynomial and figure out what p of 0 is. Okay, let's look at part B. Suppose 2 spies are actually double agents who might try to alter their parts of the message to disrupt the mission. How should Agent 0 modify this scheme? Well, instead of sending out 6 points, we can send out 8 points, p of 1 to p of 8. So even if 2 points get corrupted or are altered, right, we still have 6 good points. And we only need 6 good points to reconstruct this degree 5 polynomial. Alright, let's look at part C. After the mission, Agent 0 wants to verify the identity of each spy to identify any double agents. Assuming there were alterations in the transmitted messages, how could he use the same error-correcting scheme to identify at least one double agent? Okay, the idea is that Agent 0 could just simply identify points that don't fit the reconstructed polynomial. And if those points don't fit the reconstructed polynomial, they kind of indicate that there are some alterations there. Okay, let's look at part D. To further secure communication, Agent 0 realizes the need for a method allowing spies to detect inaccuracies in their received message parts on their own. How can they adjust the distribution of message parts to enable each spy to perform a basic self-check for errors? The idea here is that each spy receives their part in an additional point from the polynomial. And basically, each spy can perform verification using their part and that additional point. And they can see if that aligns with the polynomial reconstructed from the group's shared points. Thanks for watching.